Today we're going to start by looking at how we can name certain compounds and ions, okay, using their oxidation numbers. So the first thing we're going to do is we're going to look at how we can name certain basic anions, right? So obviously if we just have a standalone anion of a particular element, so for example if I have something like Cl minus, right, we call that the chloride ion, right? IDE, okay, it ends in IDE, right? If we have something like O2 minus, we call that the oxide ion, right? If we have something like N3 minus, right, we call that nitride, right? If you have H minus, we call that hydride, right? So it's basically the suffix over here, right, is IDE. So Cl minus, right, we have a chlorine atom with a negative charge, right? We have a chlorine anion, so that we call chloride, okay, it ends with IDE. Anion of oxygen would be oxide, anion of nitrogen would be nitride, okay, and an anion of hydrogen would be hydride, right? Other examples, S2 minus would be sulfide, Br minus would be bromide, F minus would be fluoride, P3 minus would be phosphide, and so on. Okay, so this is how you would name simple anions. Okay, now let's look at compounds. Okay, let's look at compounds in which we have anions and cations. Right, now if you have something like Al2O3, right, this would just be named aluminum oxide, right, because your cation here is aluminum, Al3 plus, right, and your anion is O2 minus, right? So you have 2 Al3 plus here, and then you have 3 O2 minuses, right? So this is aluminum oxide. You don't need to specify the oxidation number of aluminum because aluminum doesn't have variable oxidation numbers, right? It only exists as +3, right, in its compounds. But then what if you had something like Fe2O3? Now if you have something like Fe2O3, right, in Fe2O3 we have iron. Now iron can have multiple oxidation states. So in this you would have to specify the oxidation number of iron, right? So we know that oxygen has an oxidation number of -2, right? So let's say that the oxidation number of iron is X. So we can say that we have 2 irons and we have 3 oxygens, each of which is -2, and the overall oxidation number is 0. So X comes out to +3. Okay, so we know that the oxidation number of iron here is +3. So this would be iron 3 oxide. Okay, this would be iron 3 oxide. Right, we have two Fe3 pluses over here, right? This is, we have Fe3 plus and then O2 minus, right? So that would be iron 3 oxide. Similarly, of course, if we add something like FeO, right? Here we know that oxygen has an oxidation number of -2. That means iron has an oxidation number of +2. So this would be iron 2 oxide. Okay, iron 2 oxide. So because transition elements have variable oxidation numbers, right, they have variable oxidation states, we have to specify the oxidation number of the transition element present in the compound. So then how would we name this? Now over here we have manganese, okay. Let's say we don't know the oxidation number of manganese, but we know we have 2 oxygens, each of which is -2, right, because it's an oxide, and the overall oxidation number is 0, so X comes out to +4. So we know that the oxidation number of manganese here is +4, hence we can give this the name manganese 4 oxide. Okay, manganese 4 oxide. So over here again, manganese is a transition element. Okay, manganese is a transition element, and therefore we have to specify the oxidation number of manganese in this oxide. Okay, so this will be manganese 4 oxide. So now how would we name SO3? Right, now the common name for SO3 is just sulfur trioxide, right? That's the name that we're used to, sulfur trioxide. Now in sulfur trioxide, okay, sulfur, okay, has an oxidation number of +6. Okay, so for example, let's say that the oxidation number of sulfur is X, right, and we have 3 oxygens, that's each of which is -2, and we have a neutral compound, right? So that means X is equal to +6, right? So the oxidation number of sulfur here is +6, right? We have 3 times minus 2, that's minus 6, and then this would be plus 6. So this sulfur trioxide can also be referred to as sulfur 6 oxide. Okay, it can also be referred to as sulfur 6 oxide. So similar to transition elements, a lot of non-metals can also have variable oxidation states, right? A lot of non-metals can also have variable oxidation states in their ions and in their compounds. Similarly, if you look at SO2, right? SO2 is commonly referred to as sulfur dioxide. Right? Common name is sulfur dioxide, but it may also be referred to as sulfur 4 oxide. Here again, each of the oxygen atoms has an oxidation number of -2, so we have 2 times -2. So that means that's -4 for the 2 oxygens. That means sulfur has an oxidation number of +4. Okay, so it can be referred to as sulfur 4 oxide. Another example that we have is NO2, right? NO2 is commonly referred to as nitrogen dioxide. It's commonly referred to as nitrogen dioxide, but it may also be referred to as nitrogen 4 oxide. Okay, it may also be referred to as nitrogen 4. So this is nitrogen 4 oxide. Now, of course, if you're asked to name the compound, you can say nitrogen dioxide, right? However, you should be able to identify which compound they're talking about if they just said nitrogen 4 oxide. Similarly, if you're asked to name this, you can call this sulfur trioxide, that's fine. However, if they do mention the name sulfur 6 oxide or sulfur 4 oxide, you should know which oxide they're referring to. Similarly, if you look at NO, right, NO is nitrogen monoxide, okay, nitrogen monoxide, but it may also be referred to as nitrogen 2 oxide. Okay, nitrogen monoxide, but may also be referred to as nitrogen 2 oxide. Okay, because we have one oxygen here which is -2, that means the nitrogen is +2, right? It has an oxidation number of +2. This is nitrogen 2 oxide. Some more examples that we have are P4O10. Here phosphorus, okay, phosphorus has an oxidation number of +5. Okay, we have 4 phosphorus atoms, so let's say that the oxidation number of phosphorus is X, right? So we have 4X, and then we have 10 oxygen atoms, each of which is -2, and the overall oxidation number is 0. So then we get 4X is equal to +20, right? Which means that X is equal to +5. Okay, so here the oxidation number of phosphorus is +5. Okay, so this may be referred to as phosphorus 5 oxide. Okay, phosphorus 5 oxide. Then we have P4O6. Okay, that's another oxide of phosphorus. It is called phosphorus 3 oxide. Okay, here the oxidation number of phosphorus is +3. Okay, +3 times 4 is +12, and then each of the oxygens is -2. 6 times -2 is -12, right? So the overall is just 0. And then similarly, you can also apply this naming to different types of acids. So for example, H2SO4, right, commonly known as sulfuric acid, right? That's the name for this acid. Sulfuric acid may also be referred to as sulfuric 6 acid. Okay, here if you calculate the oxidation number of sulfur, it will be +6. Okay, it will be +6. We have 2 H pluses, so that's +2. We have 4 O2 minuses, right, or -2, 4 oxygens with a -2, so that's +2 minus 8, that's -6. So the one sulfur is +6. Okay, it's called sulfuric 6 acid as well. Similarly, H2SO3, another compound that we're familiar with, this is known as sulfurous acid. Okay, but it may also be referred to as sulfuric. It may also be referred to as sulfuric 4 acid, because the oxidation number of sulfur in this compound is +4. So here, if you just do the calculation, okay, for sulfuric acid or sulfuric 6 acid, right? Let's say sulfur is X, we know that the 4 oxygens are -2, and then the 2 hydrogens are +1. The overall is 0, so X comes out to +6. Okay, so the oxidation number of sulfur here is +6, hence the name sulfuric 6 acid. Similarly, if you look at sulfurous acid, right, here we have sulfur is X, we have 3 oxygens which are -2, and we have 2 hydrogens +1 each. This is equal to 0 again because it's a neutral compound, and X is equal to +4. So here the oxidation number of sulfur is +4. Okay. So if we just say sulfuric acid, we're talking about sulfuric 6 acid. Okay, but when we talk about sulfurous acid, it can also be called sulfuric 4 acid. Similarly over here, if you look at H3PO4, right, this is phosphoric acid, right, phosphoric acid. It may also be referred to as phosphoric 5 acid, okay, because the oxidation number of phosphorus is +5. Phosphoric 5 acid. Then we have H3PO3, right? The name for this acid is phosphorus acid, ROUS, phosphorus acid. May also be referred to as phosphoric 3 acid. Okay, because the oxidation number of phosphorus here is +3. Okay, so if we just say phosphoric acid, we're talking about phosphoric 5 acid. Okay, and when we talk about phosphoric 3 acid, we're talking about phosphorus acid. So now we're going to look at how we can name ions. So we're going to look at how we can name ions. So we're going to start with MnO4 minus. Now over here, right, again we have manganese bonded to oxygen, and it's an anion. Whenever we have an anion with oxygen, okay, we give it the suffix ate, so it will end with ate. So it's manganate. But we also need to find the oxidation number of manganese, right? So we know that, let's say that the manganese has an oxidation number of X, right? We have 4 oxygens, each of which is -2, and the overall oxidation number is -1, right? That's the charge on the ion. So that means X is equal to +7. Okay. So then this ion, okay, this ion is called the manganate 7 ion. Okay, it's called the manganate 7 ion. Okay, it's an anion. Whenever we have a polyatomic ion with oxygen in it, an anion with oxygen in it, we give it the suffix ate. So we have manganese bonded to oxygen in this anion, so it will be manganate, and then the 7 because the oxidation number of manganese is +7. Another example that we have is Cr2O7 2 minus. Now over here we have chromium, right? We have chromium bonded to oxygen in this polyatomic ion. First we need to figure out the oxidation number of chromium. Okay, so we have 2 chromium, so that's 2x. Each oxygen is -2, and the overall oxidation number is -2 on the ion, right? That's the charge. So X will come out to +6. So that means chromium has an oxidation number of +6. Okay, so this ion is called dichromate 6. Okay. Dichromate 6. Okay. The reason we call it dichromate is because there's 2 chromiums here. Okay, so dichrome, and then ATE because it's an anion in which we have oxygen. It's a polyatomic anion with oxygen. So dichromate 6. Okay, the 6 specifies the oxidation number of chromium. Then we have ClO minus. Now over here, okay, we know, let's say that the oxidation number of chlorine is X. We know that oxygen is -2, right? So X plus -2, right? And the overall oxidation number is -1 because the ion has a 1 minus charge. So X comes out to +1. So the oxidation number of chlorine here is +1. So this anion is called the chlorate 1 ion. Okay, it's called the chlorate 1 ion. Similarly, the ClO3 minus ion, okay, ClO3 minus is called chlorate 5. Okay, it's called the chlorate 5 ion. Okay, here the oxidation number of chlorine in this anion is +5. So we have X for chlorine, we have 3 oxygens, each of which is -2, and the overall oxidation number is -1. We get X is equal to positive 5. So the oxidation number of chlorine here is positive 5, hence we call it the chlorate 5 ion. The next example that we have is SO4 2 minus, right? Now SO4 2 minus we're all familiar with, right? This is called the sulfate ion. This is called the sulfate ion, but it is also referred to as the sulfate 6 ion. Okay, it is also referred to as a sulfate 6 ion. Okay, and the reason why is because sulfur has an oxidation number of plus 6. Okay, if let's say sulfur is X, we have 4 oxygens, each of which is negative 2, and the overall oxidation number is negative 2. We get X is equal to positive 6. Okay, so the oxidation number of sulfur is plus 6, hence we call it the sulfate 6 ion. Similarly, if we look at SO3 2 minus, okay, if we look at SO3 2 minus, we call this the sulfite ion. Okay, we call this the sulfite ion, but this may also be referred to as the sulfate 4 ion. It may also be referred to as the sulfate 4 ion because the oxidation number of sulfur here is plus 4. Okay, so when we talk about the sulfate ion, it's SO4 2 minus. Whenever we have ATE, right, that's SO4 2 minus, and then if you have one oxygen fewer, it will be sulfite. Okay, ITE. So whenever we're talking about the sulfate ion, we're specifically referring to the sulfate 6 ion. Okay, and we're talking about the sulfate 4 ion or sulfite ion. Okay, it means the same thing. When we're talking about the sulfite ion, we're referring to the sulfate 4 ion. Similarly, the phosphate ion, right? The phosphate ion may also be referred to as the phosphate 5 ion. Okay, it's also referred to as the phosphate 5 ion. All right, the reason why is because phosphorus has an oxidation number of plus 5. Okay, similarly, the phosphite ion, which is PO3 3 minus, okay, this compound or this ion is the phosphite ion, right, because it has one oxygen fewer or one oxygen lesser, hence it gets the name phosphite. Okay, but it may also be referred to as the phosphate 3 ion. Okay, it will also be referred to as the phosphate 3 ion because the oxidation number of phosphorus is plus 3. So if we're just referring to phosphate, we're talking about phosphate 5. And we're talking about phosphite, we're talking about phosphate 3. Now if you look at the ion NO3 minus, right, this is called the nitrate ion. Okay, but it may also be referred to as the nitrate 5 ion. Okay, because here the oxidation number of nitrogen is plus 5. Similarly, we talk about NO2 minus, right? Here we have one fewer oxygens instead of ATE. This will be referred to as nitrite. Okay, the nitrite ion, right? But it can also be referred to as the nitrate 3 ion because the oxidation number of nitrogen is plus 3.